So hi guys, once again welcome. Let us solve this problem. The problem statement is here. Find the support reactions for the cantilever beam loaded as shown in figure. So in this figure you can see the cantilever beam. This is the beam. This is the beam. And loaded with two UDL. This is first UDL and this is the second UDL, means uniformly distributed load. And so this one is acting in downward directions, but this one second UDL is acting in upward directions from the bottom side of the beam. And the beam is which type of beam? So it is the cantilever beam. ठीक है, लोडिंग्स किस टाइप का है? तो इट इज लोडेड बाय टू UDLs. बट व्हाट अबाउट द बीम? सो बीम is here the cantilever beam. Cantilever beam. ठीक है. So what is the identification? ये it is the beam is like fixed with the wall. You can say like wall. This beam is also known as built in beam. ओके, सो आप देख सकते हैं, कैन दिस बीम ट्रांसलेट इन x डायरेक्शन, हॉरिजॉन्टल डायरेक्शन? नो. ओके, so let us at A draw the free body diagram. So it is A. So can it translate in horizontal direction? No. So no मतलब there is a resistance HA. Can this translate in y direction? So answer is no. ठीक है. So either it can be like this way, we can show VA. ठीक है. And it can act downwards also, but and what we get the answer that will say whether our assumption was correct or not. So no need to bother about that. ठीक है. आप डायरेक्शन चाहे तो इसको लाइक VA को आप डाउनवर्ड भी ले सकते हैं, अपवर्ड भी ले सकते हैं. ठीक है. And the third question is, can this beam rotate? So it cannot rotate. ठीक है. So suppose not rotate means there is resisting moment, and this I am giving the name MA. So in this way, if you remove the support, okay, the support is fixed support. Okay, then we need to means in place of that we need to include HA, VA and the moment, and in this way we can proceed our solution. We can get that. Okay, so what we have to do, we have to firstly focus this upper one, the UVL. So what will be area that is the here, this area is actually point load. Okay, so area is its length L by 2 multiplied by this 2W. Okay, so WL is the area and that is the point load. Okay, and where it is acting? So it is acting from A. From A it is acting at the mid of this L by 2. Okay, so L by 2 divided by 2, we can L by 2 divided by 2. Okay, and this similarly for the UDL load which is acting from downwards, this one. Okay, so the area, how to find out the area? Suppose this is the area 1 and it is the area 2, and this is the P1. So area 2 it is L by 2 multiplied by W. So WL by 2, and it is equal to again the point load with or concentrated load. Okay, and same here, suppose from B or A. Okay, if we take the center of mass of this center of mass of this means P2 load. Okay, from A, so that is equal to what we have to do, L by 2 plus then this one divided by 2, this one divided by 2. So in this way we can write 4 here, and it will be 2L plus L is equal to 3L by 4, and it is from A. What about from B? From B easily we can get, you can see from B it is, the distance is the half of the beam which is loaded with the UDL, like this one, this one. Okay, so this length is L by 2 from B. Okay, and it is acting upwards. So where will be the center of mass of this load? This load means we have converted that. This is B, this is C, and this is the load P2, and this distance is L by 2. Okay, so that's why here it will be what, the where it is acting, so L by 2 divided by 2. Okay, because it will act at the center of this rectangle, so that's why L by 4 here. So let us show it, the all the forces in the free body diagram. So what we have done here, this is the free body diagram, and the beam we have shown, this is the beam. Okay, and this is the point A, point B, and this is the center of the center of the beam. Okay, and also we have located this P1 from UDL1, and where it is acting? So it is acting from end A, L by 4. And what about this one, P2 from UDL 2, okay, and from B it is L by 4. Total length is here L, the beam length, and from the middle it is L by 2. So here also the L by 2 from B. And the moment, because the cantilever beam is there, moment A, MA. Okay, so what is the next step? So satisfying the equilibrium conditions, Fx is equal to 0, and there is only HA, no one load is there to counter this. Okay, so that's why HA is equal to 0, and summation of Fy is equal to 0. Then this one VA positive direction, and P1 negative direction, P2 positive direction is equal to 0. And what about P1? P1 is equal to what? So P1 is equal to WL, and P2 is equal to, we can see here, there, this one P2. Okay, this P2. So it is WL divided by 2. So what we get from this, VA is equal to P1 minus P2 is equal to WL minus WL by 2 is equal to WL by 2. And what about moment? So summation of moment A is equal to 0. Okay, let us submit this. So it's equal to 0, and then this we are taking positive, so hence MA is acting in a anti-clockwise, that's why MA, and then P1 is acting clockwise, so with plus P1 multiplied by L by 4, and what about P2 with minus sign P2, and it is from here. So what will be, we are taking moment about A, so it will be what, L minus L by 4, and this is equal to what, it is 4L minus L divided by 4, means 3L divided by 4, and the P1 already we know, it is WL, P2 WL by 2, so, and is equal to 0. So what we get, MA is equal to minus P1 and multiplied by L4 plus P2 multiplied by 3L by 4. Okay, and P1 is equal to, we are putting here WL by 2 multiplied by L by 4. Here P2 is equal to W, so P1 is equal to, actually there is mistake, P1 is equal to WL, and P2 is equal to WL by 2 and multiplied by 3L4. Okay, so what we get, MA is equal to, and this is with minus sign, so we get WL square by 8. So all the reactions we have found out this, so writing okay, so let us do this. Okay, thank you.